National Electrical Code Table 110.34. E mandates a minimum elevation of 9 feet 6 inches for unguarded live parts situated above working space. The critical consideration lies in whether the area beneath the top bushing of a 34 kV substation transformer qualifies as working space, especially when the transformer's body occupies this zone. The National Electrical Code defines working space as the area around electrical equipment that allows personnel to safely operate and maintain the equipment. This space must be clear and unobstructed to ensure safe access for inspection, maintenance, and repairs. The dimensions of the working space are determined by the voltage of the equipment and the conditions of the installation. Working space isn't merely any area in the electrical gear, it's a designated zone intended for safe operation and maintenance. Factors like voltage levels and specific installation conditions dictate the required dimensions of this space. However, the code recognizes that not all areas surrounding electrical equipment are necessarily considered working space. The body of a transformer effectively acts as an enclosure. According to electrical codes, live parts contained within an enclosure are exempt from the specific elevation mandates detailed in Table 110.34. Therefore, the area situated below the top bushing on the 34 kV substation transformer is excluded from being classified as working space and consequently is not bound by the 9 feet 6 inches elevation stipulation. It's crucial to differentiate between exposed live parts and those shielded by enclosures. Exposed live parts necessitate specific clearances to prevent accidental contact, while enclosed live parts are deemed adequately protected, negating the need for such clearances. The National Electrical Code provides comprehensive guidelines for working clearances around electrical equipment to ensure the safety of qualified personnel. These clearances vary depending on the voltage level of the equipment and the specific working conditions. The purpose of these clearances is to provide enough space for workers to safely perform their tasks without coming into contact with energized parts. Maintaining proper working clearances is essential for preventing electrical accidents and ensuring the safe operation of electrical systems. The National Electrical Code specifies the minimum required clearances for different voltage levels and working conditions. These clearances must be maintained at all times to ensure the safety of workers and the proper functioning of the electrical system. In the case of the 34 kV substation transformer, the area below the top bushing is not considered working space because the body of the transformer provides adequate protection for the live parts. This means that the 9 feet 6 inches elevation requirement does not apply to this area. However, it is still important to maintain safe working clearances around the transformer to prevent accidental contact with energized parts. The National Electrical Code also provides guidelines for the installation and maintenance of electrical equipment. These guidelines are designed to ensure the safe and reliable operation of electrical systems. Following these guidelines is essential for preventing electrical accidents and ensuring the safety of workers. The National Electrical Code is a comprehensive set of standards for the safe installation and maintenance of electrical systems. It is important to consult the National Electrical Code for specific requirements related to working clearances and other electrical safety issues. In summary, the National Electrical Code Table 110.34. requires a minimum elevation of 9 feet 6 inches for unguarded live parts above working space. However, this requirement does not apply to live parts that are located within the body of a transformer. The body of a transformer is considered to be an enclosure, and live parts that are located within an enclosure are not subject to the elevation requirements of Table 110.34. Therefore, the area below the top of the bushing on the incoming 34 kV substation type transformer is not considered working space and is not subject to the 9 feet 6 inches elevation requirement. It is important to maintain safe working clearances around the transformer to prevent accidental contact with energized parts. The National Electrical Code provides comprehensive guidelines for working clearances and other electrical safety issues. Understanding the definition of working space is crucial. The National Electrical Code defines working space as the area around electrical equipment that allows personnel to safely operate and maintain the equipment. This space must be clear and unobstructed to ensure safe access for inspection, maintenance, and repairs. The dimensions of the working space are determined by the voltage of the equipment and the conditions of the installation. When the transformer body occupies the space beneath the bushing, it alters the classification of that area. The code recognizes that the transformer's physical presence changes the nature of the space, impacting whether it's considered working space. Enclosures play a significant role in electrical safety. The National Electrical Code recognizes that enclosures provide a level of protection for live parts. When live parts are enclosed, they are not subject to the same clearance requirements as exposed live parts. This is because the enclosure provides a barrier that prevents accidental contact with the live parts. Therefore, understanding the role of enclosures is essential for interpreting the National Electrical Code requirements for working clearances. The specific voltage of the equipment is a critical factor in determining working clearances. The National Electrical Code specifies different clearance requirements for different voltage levels. Higher voltage equipment requires greater clearances to ensure the safety of personnel. Therefore, it is important to know the voltage of the equipment when determining the required working clearances. The conditions of the installation also affect working clearances. The National Electrical Code recognizes that different installation conditions may require different clearances. For example, if the equipment is located in a damp or wet environment, the clearances may need to be increased to prevent electrical shock. Therefore, it is important to consider the conditions of the installation when determining the required working clearances. The National Electrical Code is a complex and comprehensive document. It is essential to consult the National Electrical Code for specific requirements related to working clearances and other electrical safety issues. The National Electrical Code is updated regularly to reflect changes in technology and industry best practices. Therefore, it is important to stay up to date with the latest version of the National Electrical Code. Electrical safety is paramount when working with electrical equipment. It is essential to follow all safety precautions and to consult the National Electrical Code for specific requirements related to working clearances and other electrical safety issues. Failure to follow these precautions can result in serious injury or death. Therefore, it is important to take electrical safety seriously and to always follow the National Electrical Code. The interpretation of the National Electrical Code can be complex and challenging. It is often necessary to consult with a qualified electrical engineer or inspector to ensure compliance with the National Electrical Code. These professionals have the knowledge and experience to interpret the National Electrical Code correctly and to ensure that electrical installations are safe and compliant. The National Electrical Code is a valuable resource for ensuring electrical safety. By following the National Electrical Code, we can protect ourselves and others from the hazards of electricity. Therefore, it is important to take the time to learn about the National Electrical Code and to follow its requirements. In conclusion, the area below the top bushing and the incoming 34 kV substation type transformer is not considered working space and is not subject to the 9 feet 6 inches elevation requirement. However, it is still important to maintain safe working clearances around the transformer to prevent accidental contact with energized parts. The National Electrical Code provides comprehensive guidelines for working clearances and other electrical safety issues. It is essential to consult the National Electrical Code for specific requirements related to working clearances and other electrical safety issues. Always prioritize electrical safety and follow all safety precautions when working with electrical equipment. The National Electrical Code addresses several key aspects of electrical safety related to working space. Firstly, it defines the minimum dimensions of working space required around electrical equipment operating at different voltages. These dimensions are specified to provide sufficient room for workers to safely approach and perform tasks on the equipment. Secondly, the National Electrical Code outlines the conditions under which working space is required. This includes situations where live parts are exposed and where workers may need to access the equipment for maintenance or repair. Thirdly, the code specifies the types of obstructions that are not permitted within the working space. This includes items that could impede access to the equipment or create a hazard for workers. Fourthly, the National Electrical Code addresses the illumination requirements for working space. Adequate lighting is essential to ensure that workers can see clearly and avoid potential hazards. Fifthly, the code includes provisions for the protection of workers from electrical shock and arc flash hazards within the working space. This includes requirements for personal protective equipment and procedures for de-energizing equipment before work begins. Finally, the National Electrical Code provides guidance on the training and qualifications of workers who are permitted to work within the working space. This ensures that workers have the knowledge and skills necessary to perform their tasks safely. By addressing these key aspects of electrical safety, the National Electrical Code helps to protect workers from the hazards associated with working around electrical equipment. It is essential to comply with the National Electrical Code requirements for working space to ensure a safe working environment. The application of Table 110.34 involves several steps. Firstly, determine the voltage of the electrical equipment. This will determine the minimum required elevation for unguarded live parts. Secondly, identify the working space around the equipment. This is the area where workers may need to access the equipment for maintenance or repair. Thirdly, determine whether there are any unguarded live parts located above the working space. Unguarded live parts are those that are not enclosed or protected by insulation. Fourthly, measure the elevation of the unguarded live parts above the working space. If the elevation is less than the minimum required by Table 110.34 then the live parts must be elevated to meet the requirement. Fifthly, ensure that the working space is clear of any obstructions that could impede access to the equipment or create a hazard for workers. Finally, provide adequate illumination in the working space to ensure that workers can see clearly and avoid potential hazards. By following these steps, you can ensure that your electrical equipment complies with the requirements of Table 110.34 and that your workers are safe. The 9 feet 6 inches elevation requirement in Table 110.34 is intended to prevent accidental contact with energized parts. This requirement applies to unguarded live parts located above working space where workers may need to access the equipment for maintenance or repair. The elevation requirement provides a safe distance between the energized parts and the workers, reducing the risk of electrical shock or arc flash. The 9 feet 6 inches elevation requirement is based on the height of a typical worker and the reach of their arms. This height is considered to be sufficient to prevent accidental contact with energized parts. However, it is important to note that this is a minimum requirement and that higher elevations may be required in certain situations, such as where workers are using ladders or other elevated work platforms. In addition to the elevation requirement, it is also important to maintain a safe working distance from energized parts. This distance is determined by the voltage of the equipment and the type of work being performed. The higher the voltage, the greater the required working distance. It is also important to use appropriate personal protective equipment when working near energized parts. This includes items such as gloves, sleeves, and face shields. By following these safety precautions, you can reduce the risk of electrical shock or arc flash and ensure a safe working environment. The National Electrical Code is a comprehensive set of standards for the safe installation and maintenance of electrical systems. It is important to consult the National Electrical Code for specific requirements related to working clearances and other electrical safety issues.